Hello everyone. The topic for today is methods to turn on an SCR. The first method of triggering is called as forward voltage triggering. In forward voltage triggering, the SCR is forward biased, that is, the anode is positive with respect to cathode and the gate circuit is open. Since the SCR is forward biased, junction J1 and junction J3 are forward biased and junction J2 is reverse biased. There is a depletion layer formed at junction J2. The width of the depletion layer of junction J2 is a function of anode to cathode voltage. As the anode to cathode voltage increases, the width of the depletion layer at junction J2 decreases. When the anode to cathode voltage is increased beyond a certain voltage called as forward breakover voltage, the depletion layer at junction J2 vanishes. This phenomena is called as avalanche breakdown. After the voltage increases slightly beyond forward breakover voltage, the operation of the SCR shifts from forward blocking to forward conduction state. In forward conduction state, the voltage drop across the SCR is very small, whereas the current is very large. Once the SCR is turned on, junction J2 loses its reverse blocking capability. Even if the voltage is brought below VBO, the SCR will not turn off. The SCR will turn off only when the anode to cathode current is brought below holding current. Turning on an SCR by increasing the voltage beyond forward breakover voltage is not followed often. This is because the SCR may get damaged. The next method of triggering is called as gate triggering. In forward voltage triggering, we had observed that in order to turn on the SCR, we had to increase the voltage across the anode to cathode beyond a certain voltage called as forward breakover voltage. This voltage is very large. In order to turn on the SCR at lower voltages, gate triggering is used. In gate triggering, the SCR is forward biased with a voltage applied across anode to cathode and a positive voltage is applied across gate and cathode. When a positive voltage is applied across gate and cathode, the free electrons from the lower N layer are injected into the inner P layer. This is because the N layer is highly doped and P layer is lightly doped. These free electrons reach junction J2. Since the free electrons reach junction J2 and the SCR is forward biased, the width of the depletion layer at junction J2 decreases and the depletion layer at J2 vanishes. With the depletion layer of J2 vanishing, the SCR turns on. Once the SCR turns on, gate current is not necessary in order to maintain the SCR in on condition. We can remove the gate current. Higher the value of gate current, lower is the value of the voltage at which the SCR is turned on. As you can see in this diagram, for no gate current, the SCR turns on at a forward breakover voltage of VBO, which is very high. And for higher gate currents, the SCR turns on at lower breakdown voltages. Latching current is defined as the minimum value of anode current which the SCR must attain during turn-on process to maintain conduction when gate signal is removed. The thyristor can be turned off only when forward current falls below a low level current called as holding current. Holding current may be defined as the minimum value of anode current below which it must fall for turning off the thyristor. Latching current is associated with turn on process. Holding current is associated with turn off process. The next method for triggering is called as dV by dt triggering. In dV by dt triggering, the anode is positive with respect to cathode and gate is open. Junction J1 and junction J3 are forward biased. Junction J2 is reverse biased. Depletion layer is formed at junction J2. Depletion layer formed at junction J2 acts like a dielectric. Therefore, junction J2 behaves like a capacitance. The charging current for a capacitor is given by IC is equal to dq by dt. If we substitute the value for Q as Cj into Va, where Cj is the junction capacitance and Va is the anode to cathode voltage, and suppose we differentiate this term, we will have IC is equal to Cj dVa by dt plus Va dCj by dt. Since the term Cj is constant, dCj by dt is 0 and this term Va dCj by dt will be 0. Therefore, charging current will be given by IC is equal to Cj dVa by dt. The same is written over here, IC is equal to Cj dVa by dt. When the value of dVa by dt is very large, the charging current is very large. This charging current will act like gate current and it can turn on the SCR. This happens when we apply a step voltage. When we apply a step voltage, at time t equal to 0, the voltage varies from 0 to V volt. If the value of voltage is very large and at time t equal to 0, the voltage changes from 0 to V volt, the rate of change of voltage during this time is very large. dV by dt is very large during time t equal to 0. Since dV by dt is large, IC is large. Since dV by dt is large, IC is large, and this charging current acts like gate current, which in turn turns on the thyristor. During forward blocking, most of the applied voltage appears across junction J2. The voltage across J2 associated with leakage current would raise the temperature of this junction. With increase in temperature at junction J2, the width of the depletion layer decreases. This further leads to more leakage current and therefore more junction temperature. With the cumulative process, the depletion layer at J2 vanishes at some high temperature and the device gets turned on. For light triggered SCRs, a recess or niche is made in inner P layer as shown. When this recess is irradiated, free charge carriers are generated just like when gate signal is applied between gate and cathode. The pulse of light of appropriate wavelength is guided by optical fibers for irradiation. If the intensity of this light thrown on the recess exceeds a certain value, forward biased SCR is turned on. Such a thyristor is called as light activated silicon controlled rectifier.